Note 60. So today the goal is going to be that you learn how to solve a right triangle and how to identify angles of elevation and depression. So two goals today. First, if you're ever asked to solve a right triangle, what that means is when you solve a right triangle, you want to find the lengths of all three sides, and I want to know the measure of all three angles. So if you're asked to solve a right triangle, what I'm going to ask you is to find the length and measure of all three sides and angles. I want to find all 6 parts. They all have to have values. So to do that, guys, at this point, we've now spent several days talking about right triangles. Depending on what information you're given, you have different techniques that you can use. So first, if you know 2 side lengths, then you can find the missing third side length with the Pythagorean theorem. That's when this is applicable. Next, if you know 1 side length and 1 acute angle, then you can find unknown sides using SOHCAHTOA. Lastly, if you know 2 side lengths and you want to find a missing angle, then you can find an angle using inverse trig ratios. Guys, among this as well is you have special right triangles that you could also use when you recognize that you have that special case or those special cases. So example A, it says solve the right triangles, round each side length to the nearest tenth, so each side length to the nearest tenth, and each angle measure to the nearest degree. So each angle measure, I want the nearest whole degree. So in example A, here's what it says. I want to solve this right triangle. So if you think about this right triangle in terms of its 6 parts, you're given some information to start. So first, you're given that angle A is 30 degrees, so that's given to you. So here, the measure of angle A is given to me at 30 degrees. You're also given that angle C is a right angle, so angle C, the measure of angle C, that's 90 degrees. And you're also given to start that the side AB here is going to be 2. So you're given that AB, that's a side, that's equal to 2. So that's given to you to start. So to solve the right triangle, you have to compute 3 additional parts that are not given to you. In this case, the easiest part to compute here would be angle B, because if this is 30 degrees, this is going to be 60 degrees. So that I can find pretty easily just with my basic triangle facts. Now the parts that I still don't know at this point are sides BC and sides AC. So now here you have to compute those, and you have choice. Guys, in this case, when I look at this triangle, I see a 30, 60, 90, so I'm going to opt to use the special right triangle 30, 60, 90 here to find my missing sides. Okay, so I have a 1 to radical 3 to 2 comparison. Now if I place this ratio on my triangle, look at what you see. It's a 1 to radical 3 to 2 comparison. In this example, it actually works out here that the hypotenuse I know will be twice as long as my short side. But in this case, if my hypotenuse itself is 2, half of 2 is equal to 1. So here my missing side BC is going to be 1. And then to find the middle side, I can multiply up by a factor of radical 3. So 1 times radical 3 here just happens to be radical 3. So I can find here my missing side lengths to be 1. BC is equal to 1. So here I'll put it in blue. BC is equal to 1. That's your short side. And then AC is equal to radical 3. So at this point, if you look at the triangle now, notice how every part, all 6 parts, all 3 angles have a degree measure, all 3 sides have a length. Example B. So in this case, again, I want to solve the right triangle, so I want to find all 6 parts of the triangle. First, parts are given. Here, I'm given angle C is a right angle, so I can say the measure of angle C equals 90 degrees. I'm given here 2 additional sides. I'm given here that AC is equal to 6, so AC, that's a side, is equal to 6. And I'm also given that this side here, BC, is equal to 7. So I can say BC, the side BC is equal to 7. In this case, what I don't know is I don't know this hypotenuse length, nor do I know the angle measures here of angle A or angle B. So I have to compute these. So first, I'm going to find AB. Now in this case, remember that if I know two side lengths, I can use the Pythagorean theorem to find the missing third side. So here, to find AB, I'm going to use the Pythagorean theorem. So I'm going to say a squared plus b squared equals c squared. So here it's going to be 6 squared plus 7 squared equals ab squared. Again, ab is the side that I don't know. 6 squared is 36, 7 squared is 49. That equals to my hypotenuse squared. Adding those together, I get 85 equals to ab squared. And then we learned to cancel the square, we take a square root. So here I get that AB equals to the square root of 85. But in this case, to round to my nearest tenth, if I use a calculator, I'm going to get 9.2. Again, I can press on the calculator, and the square root of 85 is going to be approximately 9.2. So this side here is going to be 9.2. So now we found that side AB is 9.2. Next, to find my missing angles here, I'm going to choose to use SOHCAHTOA. So again, I'm going to first start here by I'm going to look to find the measure of angle B first. So if that's the case here, I'm going to choose angle B as my reference angle. So I'm going to choose, this is my reference angle. So with that, my hypotenuse is 9.2. The side opposite angle B is going to be 6, so that's going to get my O for opposite, and then my adjacent side is going to be 7. In this case, notice how all three sides have a length. So in terms of SOHCAHTOA, I can choose whatever I want because they all have lengths. So for me, just out of simplicity, I feel like I'm going to choose 6 and 7 because they're integers, so I figured it'll be easier to work with those. So I'm going to use O and A. So that OA from SOHCAHTOA is going to be tangent. Because in fact, let me be a little bit clearer so I'm not just saying stuff on the video. So again, if I'm going to choose O and A, that's going to be TOA, so I'm going to choose tangent. So I'll use tangent of angle B, which I don't know yet, equals opposite, which is 6, over adjacent, which is 7. And at this point, I can cancel tangent with the inverse of tangent. So I'll multiply inverse tan to both sides. And so these cancel. And so angle B comes out free and clear. And that's going to equal to the inverse tangent of 6/7. From here on your calculator, you can just press those buttons, and you'll get that, in this case, the measure of angle B is approximately 41 degrees. So I've now found that the measure of angle B is 41 degrees. So if I place that here in the picture, if this is 41 degrees, then to finish this problem, I have to still find angle A. But guys, we know in a right triangle, these two acute angles have to add to 90. So if this angle here is 41 degrees, then what would this be if they have to make 90? Think about it for a second, it's going to be 49 degrees. Because 49 plus 41, that's going to be 90. So at this point in the problem, I've now found all 6 parts of my triangle. So I've now solved my right triangle. Okay, example C. Again, we want to solve this right triangle, so first think about what's given to you and what do you have to compute. In this case, you're given angle C is a right angle, so I can write the measure of angle C is 90 degrees, that's given to me. I'm also given that the measure of angle B is 56 degrees, so that's also given to me, so the measure of angle B is 56 degrees. And I'm given here that the side AC has a length of 16.3. So side AC equals to 16.3. What I don't know in this case is I don't know angle A, so I'm missing the measure of angle A. I also don't know side BC, so that's not there. And I also don't know the hypotenuse AB. So in this case, I'm missing those three parts that I have to compute. The first thing that I would do is I would find the measure of angle A. And again, we know that in a right triangle, the two acute angles, whoops, that was pointing. So we know that the two acute angles have to add to 90. So to compute angle A, all I have to do is take 90 and take away the 56 that's given to me. And I can find here that angle A is going to be 34 degrees. This is a pretty quick find in this problem. So the measure of angle A is 34 degrees. With that, I now have to find two sides, BC and AB. Notice how in this case, 34 degrees and 56, this is not going to be a special right triangle. So I'm going to have to use SOHCAHTOA to find these sides. So first, let's go ahead and find BC. So to find side BC, if I choose angle B as my reference angle, so I'll choose this, I can label my triangle as hypotenuse, opposite, and adjacent. Now, if I want to find BC to start, I'm going to use the adjacent side and then the opposite side because it has a length for me. Notice how the hypotenuse here is still blank. So to find BC, I'm going to use adjacent and opposite. Guys, in SOHCAHTOA, so again, if I give you the reference, in SOHCAHTOA, if I'm going to use opposite and adjacent, that's going to be tangent. So I'm going to choose tangent here. So I'm going to write tangent of 56 degrees equals opposite over adjacent, which is my unknown side. In this case, this is going to be a proportion, so I'm going to use cross product. So I'm going to get side BC times tangent of 56 equals 1 times 16.3 is just 16.3. Because in these questions, please don't get lost by the messiness of it. Just think about what's happening step by step. To solve for this missing side BC, I can here divide by tangent of 56 to both sides. So divide by tan of 56. So this cancels out. So I find that BC equals to, because again at this point, this is the job of the calculator. So if you press 16.3 divided by tangent of 56, you get approximately 11. Oops. So the length of side BC is going to be 11. Now with that given to you, so this is 11, all I have left to find is side AB. So again, to find side AB, I'm going to again use, in this case, I'll choose to use SOHCAHTOA one more time. So given the same triangle, if I want to now find this side here, I'm going to use, I'll just use, it doesn't matter, you can pick. I'll use opposite and hypotenuse, because now I'm looking for this side. So opposite and hypotenuse. So at OH is going to be sine. So in this case, I'm going to say sine of the same reference angle equals opposite over my missing side AB. And that's just going to be this side here. If we get the work, this has the same work as the previous example here. So this is a proportion. So cross product. So I get side AB times sine of 56 equals 1 times 16.3 is just 16.3. And to finish here, I'll divide by sine of 56. So that cancels. So here, AB equals, and again, once you get to this point, this is the job of the calculator. When you press those buttons, you get approximately 19.7. So with that, we've now found all the missing parts of this triangle. So now every angle here and every side has a value. We've solved the right triangle. Okay, our second goal today is going to be, what is an angle of elevation and an angle of depression? So in this case, an angle of elevation is an angle formed by a horizontal line and a line of sight to a point above the line. So an angle of elevation means that you're going to be looking up. So in this case, I'll use blue here. An angle of elevation means that you're going to be looking up at something. And so here, if this is my line that's horizontal, and I'm looking up at the plane, so I'm looking up at the plane, then the angle of elevation is going to be here, angle 1. So remember, it's going to be looking up. An angle of elevation is when you look up at something, the angle that creates. An angle of depression is an angle formed by a line that's horizontal and line of sight to a point below you. So here, an angle of depression is going to be a line horizontal and you looking down at something below you. So here, this would be an angle of depression. This is when you're looking down at something. So if we can identify angles of elevation and depression, then we can work with those when they come up in word problems when you hear those phrases. So example D. You are 50 feet from the screen at a drive-in movie. The angle of elevation to the top of the screen is 58 degrees. How tall is the screen? Again, because it's an angle of elevation, think about I'm looking up from my car to the top of the screen. So it's an angle of elevation here. So here what it says is you are 50 feet from the screen, so here's your 50 feet. You have your angle. I want to find out how tall is the screen. So I'm looking for this length, or this height, I guess. So I'm going to call this x. Well guys, in this case, this is a right triangle. And so here, notice how this is 58 degrees. This is not a special right triangle. So in this case, I'm going to use SOHCAHTOA to help me find the missing side. So if I choose my reference angle, I'll choose this 58 degrees. Here's my hypotenuse, my opposite side, and my adjacent side. Notice how in this case, if I want to solve for x, I'm going to use the opposite side, and then also the adjacent side because it has a value. Here, the hypotenuse doesn't give me a length, so I really can't use it yet. So I'm not going to use it. So here, I'm not going to use h, I'm going to use O and A. So in SOHCAHTOA, O and A is going to be tangent. So I'll write tangent of my angle here is 58 degrees equals to opposite, which is my x, over adjacent, which is 50. And then I can solve this. So multiply both sides by 50. And then guys, again, at this point, this is the job of a calculator. If I just press those buttons, I get it's going to be approximately 80 feet. So the height of the screen is 80 feet. Example E. Here it says a sonar operator on a ship detects a submarine at a distance of 500 meters. So from the sonar to the actual submarine is 500 meters. And an angle of depression of 40 degrees. Remember, an angle of depression means you're looking down at something. So it's going to be at 40 degrees. How deep is a submarine? So in this case, to find depth, I'm curious about this side length here. So I'm looking for the depth here. So I'll call this my x. So again, this is just a right triangle question, kind of hidden in a word problem. So again, I'll use SOHCAHTOA. So here I'll use SOHCAHTOA. And remember that when I use SOHCAHTOA, this is dependent on choosing a reference angle from one of my acute angles. So here I'm going to choose the 40 degrees as my reference angle. Given that, my hypotenuse will be the 500, so I'll put an h here on the hypotenuse. From my 40 degrees, the side opposite is going to be the x. This is my opposite side. Then this is my adjacent side. Again, in this case, notice how in this example, I'm looking for x, so I will use the opposite. And I know the hypotenuse is 500, but I don't know the adjacent side. So I really can't use this for this problem. So I'm going to not use the a, so I'm going to use O and h. Well, OH here is going to be sine, so I'm going to pick sine. So sine of my angle of 40 degrees is opposite over hypotenuse. And then I solve. So multiply by 500 to both sides. So again, here with the calculator, I just press 500 times sine of 40. And I get that the depth of my submarine here is approximately 321.3 meters. Again, that's just with the calculator. Example F. Now, in this case, notice how example F has no picture, unlike the ones you had above this one. So here, let's read the little prompt and draw a sketch of what's going on. Given a child is standing across the street from his apartment, his mother is on their balcony. So let me first draw that, and this is going to be terrible, so I do apologize. So there's a kid that's across the street from his apartment, and mom is on a balcony. So this is not the scale, so again, please don't think this is the scale, because it's not. So this is a balcony, so here's mom, and here's child, okay? We'll just go with that. It says the angle of elevation between the child's eyes and his mom's eyes is 22 degrees. So you can think about this. An angle of elevation is going to be from his eyes looking up to her eyes. It's going to be 22 degrees. Then it says if the distance between their eyes is 32 feet, so from his eyes directly across to her eyes, if this is 32 feet, how far is the child standing from his apartment building? So then I want to know how far is this child from the building? What is this missing side? This is my x. So at this point, if I think of this as a triangle, this is a right triangle, and I have this information. Because again, whenever I draw my kind of bad drawings here, I like to redraw the triangle without the story, because it makes it easier to just think about solving for x instead of the whole actual story. So here's the triangle itself. It's a right triangle with an angle of 22 degrees, side of 32. I'm looking for this side. So here again, this is not a special right triangle, so I'm going to just use SOHCAHTOA one more time. So I'm going to use my trig ratios. So again, I'll pick my reference angle, which is 22 degrees. My hypotenuse is 32. The side opposite the angle I chose is going to be this blank side. That's my opposite side. This is my adjacent side. In this case, I'm going to use A and H. So A and H is going to be cosine. So I'm going to say cosine of my angle of 22 degrees equals adjacent over hypotenuse. I'm going to solve this equation by multiplying by 32 to both sides. And so again, at this point, this is the job of the calculator. So if I put 32 times cosine of 22, I get that x equals to approximately 30 feet. So the child is 30 feet away from his building. Alright, classwork 60, number 1. In this first example, there's 4 little questions. I just want you to identify from the picture, are each of these angles going to be angles of elevation, which I'll put in blue, or of depression, which I'll put in red. So guys, again, an angle of elevation is that you're looking up, so looking up, and then an angle of depression is that you're looking down. Think of it that way. So for A, angle 1. In angle 1, notice how this guy is looking down at that's a boat, I guess, guys. This is going to be an angle of depression. I'm going to be lazy, I'm going to put DEP, but that means angle of depression, okay? For angle 2 is the guy in the boat looking up at the guy on the cliff. So this is going to be an angle of elevation as he looks up. So I'm going to be lazy here, I'll put ELE for elevation. Angle 3, here's the guy in the boat looking down at a swimmer. So again, if he's looking down at a swimmer, that's an angle of depression. And then lastly, angle 4 is going to be the swimmer looking up at the man on the boat. So if you're looking up, that's an angle of elevation. So elevation for this one. Okay, number 2. It has 2 parts. So it says find the value of x rounded to the nearest tenth. So in 2a, here's just a generic triangle. It's a right triangle, but notice how it's not special. So I'm going to use here SOHCAHTOA to compute that missing side labeled x. So again guys, I'm going to pick a reference angle. Here my hypotenuse is going to be the x. The side opposite the angle 54 that I've chosen will be 35. That's my O. And this is my adjacent side. Again, once I've labeled my triangle, here notice how the adjacent side is blank, so I can't use it. So I'm going to use O and H. That's going to be sine. So I'm going to pick sine here. So I'm going to write sine of the angle that I've chosen, 54 degrees, equals opposite over hypotenuse. And then at this point, this is a proportion, so I can now solve using cross product. X times sine of 54 is x sine of 54 equal to 1 times 35 is just 35. I can now divide by sine of 54 degrees to both sides. This cancels, so x equals 2, and with a calculator, I can just press that in. So 35 divided by sine of 54 is approximately 43.3. To my nearest tenth, it's 43.3. So I found the hypotenuse here to be 43.3 inches. 2b. So in this case, there's a little story. There's a guy staring at an apple in a tree. And I want to find out how far is the guy from the tree. So here, again, this is not a special right triangle, so I'm going to use SOHCAHTOA one more time. So I'm going to use SOHCAHTOA. Again, first picking a reference angle, so that's 13. So my hypotenuse will be 50, side opposite and side adjacent. Because at this point, because I'm not going to use the opposite side, I'm going to use A and H here. I'm going to use cosine. So I'm going to say cosine of 13 degrees equals adjacent over hypotenuse. And I can solve the equation by multiplying by 50 to both sides. And once I'm here, this is the job of the calculator, so x equals to 48.7. Sorry guys, that came out kind of messy. 48.7 feet. So in this case, the length of the distance between the guy and the tree is about 48.7 feet. Alright, number 3. So here, this is kind of the big goal for today. How do we solve a right triangle? What does that mean? So to solve a right triangle means that we want to find all 6 of its parts, the 3 angles and the 3 sides. In this example, you're already given some information. So here, angle A is already given to you as 40 degrees, so you know that. Also, angle C is a right angle, so that's also given to you. So I know the measure of angle C is 90 degrees. And then I also give you guys a side length here, which is BC is 19. So the side BC I know is 19 units. What I don't know in this triangle to start is angle B, so I'm missing the measure of angle B. I also don't know side AC, and I also don't know the hypotenuse AB. I don't have that length. So my task is to find these 3 missing parts. First, angle B should be easy because in a right triangle, the 2 acute angles have to add to 90. So if this is 40, this is going to be 50. This should be a pretty easy fill-in for everybody. So there I found that other angle. Next, I'm going to now focus on finding AC. So to find AC, because this is not a special right triangle, I'm going to again revert to SOHCAHTOA to find it. So I'll pick my reference angle, label my hypotenuse, opposite, and adjacent. In this case, if I'm going to work on finding first this AC side, notice how the hypotenuse right now is blank, so I can't use it, so I have to use opposite and adjacent. Guys, again, if I give you SOHCAHTOA one more time so you can look at it, hopefully at this point you can just do it in your head, but so if I'm using opposite and adjacent, that's going to be tangent. So I'm going to say tangent of 40 degrees equals opposite over adjacent. And in this case, I'm going to now use cross product to solve the proportion. So I get x times tangent of 40 equals to 1 times 19 is just 19. I can then divide by tangent of 40 to both sides. And I get that x equals to, again with a calculator, if I press 19 divided by tangent of 40, I get approximately 22.6. So this is going to be the length of AC here. So I've now found AC to be 22.6. So with that being identified as 22.6, my last question is to find the hypotenuse, AB. So to find AB, using the same reference angle that I've chosen, I'm going to use opposite and, in this case, the hypotenuse. So I'm looking for this side. So opposite and hypotenuse is going to be sine. So I'm going to write sine of 40 degrees equals the opposite over the hypotenuse. Now in this case, I'm going to just call the hypotenuse the actual side. I'm going to give it the actual side name. So this is side AB. So I'll put that here. Can I solve this? This is a proportion, so I'm going to use cross product. So AB times sine of 40 equals 1 times 19. I can divide by sine of 40 to both sides. So this cancels out. So here, the last side here, AB, is equal to, again with a calculator, if I just press 19 divided by sine of 40, I'll get approximately 29.6. So I've now found all 6 parts of my right triangle, which means that I've solved my right triangle.